derivatives of a to the x and log x base a. This should be x. Log x base a. But before we do this, before we find derivatives, so far we have been using base 10 and base e. So when we say y equals log x, that automatically means base 10. So if there's no base, when we say natural log of x, that automatically it's log x base e. Remember, e is about 2.7. And one of the examples where we use different base, maybe we can use different bases other than 2 and e, such as base 2 or base 3, etc. So let's say you have a kind of bacteria is presented somewhere, okay? And let's say the bacteria doubles in size every, let's say, 5 hours. What does that mean? It means after the first 5 hours, the initial population of the bacteria will become, let's call the initial population p sub 0, will become 2p sub 0. And after 10 hours, it will become quadrupled, right? Quadrupled, 4p sub 0. Or you can say 2 square p0, because 4 is 2 square. After 15 hours, it will become 2 to the third p0 times p sub 0. So the general form, if it keeps going this way, we say after t units of time, the population has doubled. T over capital T times, where t is t units of time. Now we can use an exponential function to model the growth, of the bacteria. We use p of t equals p sub 0 times 2 raised to kt. K is 1 over capital T. T is in hours. Now this is base 2. Can it be any base? Yes. For, let's say, base n exponential growth, is given by P of t equals P sub 0 times nt over capital T, because I replace k with 1 over capital T. P sub 0 is the initial amount, or initial population, or quantity. We can look at an example how to apply this. Let's look at the example. The population of bighorn doubles every 18 years. Its population was 2,500. Part A, find an exponential function using base 2 that gives the population P of t of bighorn after t years. The formula we gave you was P of t equals P sub 0 sorry, not E, I'm used to write E, N T over capital T. T over capital T. What is N here based on this problem? What is N? T is just T. What is N and what's capital T? And P sub 0. So remember, N is the base, which is given to us as 2. It says base 2. T, we don't know the T, the time, but it doubles every 18 hours, years, so 18. And the initial population was 2,500. So now all we have to do is substitute those into this equation. P of t is 2,500 times N is 2, T over 18. That's all we have to do. There's no calculation, further calculation to be done. They said just find an exponential function. Part B, find an equivalent exponential function using base E. Using base E. They are asking us to write P of t in the form P of t equals P sub 0 e to the kt. And to do so, note something here in the box. E, one of the properties, E natural log of anything, say A, is always A. E natural log of anything is that thing itself. Okay, so how do we use this to help us? Let's go back to part A. From part A, we had the equation 2500 times 2 t over 18. 2500 times, what I'm going to do here is keep t over 18 the same. So what I can do, I can take a number 2 and write it as e natural log of 2 based on the formula right above it, based on this formula. So instead of this 2, I'm going to replace it with e natural log of 2. And then we put the natural log of 2 in the calculator. That gives me e to the 0.69315 all raised to t over 18. Then watch how we finish this up. 2500 e 0.69315 times t over 18. So over 18t, like that. And if you calculate this out, you get P of t equals 2500 E. If you do the division, this division, I got 0.03851 t. So I was able to rewrite that in this form. One last part on this, without using the calculator. Find Bighorn's population after 36 years. Well, if you try to take this box answer we just got, P of t equals 2500 E 0.03851 t, and use t as 36. How am I going to calculate this? It's not easy to find. Right? So why they said calculate without the use of the calculator? Well, let's see. Remember where this box formula came from, or equation. Where did it come from? Well, it came from the original equation that we got in part A, this boxed one. All we did is we rewrote this in the other form in base E. So let me write that one down, P of t. So we say from part A, we had P of t was 2500 times 2t over 18. Okay, so now if I substitute t36, 2500 times 2, 36 over 18. So let's see what do you think that's gonna give us here in this case? What is that gonna give us? 36 divided by 2, it works out nice as 2. So P of 36 is 2500 times 2 to the second power. P of 36 is 2500 times 4. And how do you finish this up? Well, you can multiply 25 by 4, that's 100. And there are 2 more zeros you can bring down. So that gives us 10,000. 10,000. So now we may look at the derivative of a to the x, or I'm going to look at a of f of x, not just x, any function. So a raised to any function. So what's the, if we have y equals a to any function, then, so if y is given this, y prime is the derivative of the exponent times itself times natural log of the base. I can prove where that came from, but a lot of students, they don't pay attention to it later on, like they forget about it. So to practice on this formula, find y prime, which is dy dx, if part 1, y equals 5 to the x, or y equals 3 to the 5x minus 1. So to find the first one, y prime, it says the derivative of x times the function itself times natural log of the base. Derivative of x is 1. So that gives me just 5 to the x natural log of the base. For this one, derivative of the exponent times itself times natural log of the base. Of course, we assume you guys know how to find derivatives from previous sections. Derivative of 5x is 5 minus derivative of 1 is 0 times 3 to the 5x minus 1 times natural log of 3. How about y equals 7 to the x to the 4th minus 1? 2.5 raised to negative x squared. answers. So for the first one, y prime is the derivative of this times itself. Oops. ln of 7. So y prime is the derivative of this is 4x cubed times itself times natural log of the base. For number 4, we have y prime is the derivative of the exponent times itself times natural log of the base 2.5. Y prime is negative 2x times 2.5 to the negative x squared times natural log of 2.5. For the product rule, if you have u times v, the derivative is derivative of the first one times the second one plus the first one times the derivative of the second one. The derivative of the first one is 10x times 3 to the x to the fourth plus, this stays the same. Derivative of the next one is the derivative of the top based on the formula times itself times natural log of the base. Then x times 3 to the x to the fourth plus 5x squared times 4x cubed times 3 to the x to the fourth times natural log of 3. And this stays the same, but this becomes, you can multiply the 5 and the 4, which is 20. 20x to the fifth times 3x to the fourth times natural log of 3. For the last one, this number in the front is just a constant. Derivative is basically derivative of this, which is the derivative of the exponent times itself times natural log of the base 0.023. Y prime would be derivative of t is 1, so that gives us 2500 times 0.023 to the t power times natural log of the base. You may leave it like this, or if you like, you can multiply the 2500 by natural log of 0.023, and that would give us negative 9430.65 times 0.023 to the t power. You can do it this way or the previous one. Last thing is how to find derivative of log f of x base a. Well, there's a formula. If y equals log f of x base a, then what is y prime? Y prime is, watch how this is gonna go, the derivative of f prime of x over f of x itself times natural log of the base. So for the first one, y prime is the derivative of 3x, which is 3, over itself times natural log of the base. Notice how the trees cancel, so you get 1x down there. Next one, -8 is a constant, so you don't have to worry about it. There's no base means base 10. Derivative of x is 1 over itself means over x times natural log of 10. That's all you need to do. For the next one is the derivative of this, which is 4x cubed minus 0 over itself times natural log of the base. For the last one, I see a product sign, so we have to use product rule, which says you take the derivative of the first one times the second one, plus the first one times the derivative of the second one. Derivative of x squared is 2x, log of x, plus x squared. Derivative of log of x is the derivative of x itself, this one here, 1 over itself, natural log of 10, because the hidden base is 10. Now 1x cancels with 1x as a simplifying process, so 2x log x stays the same, on the top x left and the bottom natural log of 10. Anyone has any questions? Yeah, that's why I told you about base 10. If log has no base, automatically means base 10.